All right, so what is a sequence? It's a function whose domain is set of positive integers. So what's the first positive integer? 1, 2, 3, dot, dot, dot. So in that order, and whose range is a subset of real numbers. All right, so the numbers in this ordered list are called terms of the sequence. Now, we use subscripted letters to represent specific terms in the sequence. So if you have a sub 1, that's the first term. A lot of times you just use the letter A to represent terms in the sequence. A, obviously, A sub 3. Okay. All right, let's see. The screen to stay up. All right, let's see. Okay, sometimes a formula is the term is the nth term. So nth means just some position, right? So let's say, for example, if the sequence f of n is equal to 1 over n, this means the first term, n is 1. A sub 1 is 1 over 1, which is 1, right? A sub 2 is 1/2. A sub 3 is 1/3. Obvious, right? So pretty simple to determine all the terms in the sequence. So A sub 4, dot, 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 right? A sub n is equal to 1 over n. All right, so if I want to determine a formula that defines A sub n, defining the nth term can be written like this. We use braces, denotes a set, right? Squiggly lines, that means a set. That's the set of elements in here. So it's the set of all of the terms in the sequence is defined as its rule. as a set defining the rule. Let's say n plus 2 divided by n. So now if I want to say, what are the first 6 terms of the sequence? A1, A2, A3, A4, A5, A6, what are they equal to? I tell you, nobody misses this on the test. This is way too easy. Put in 1, 1 plus 2 is 3, divided by 1, 3. Put in 2, 2 plus 2 is 4, divided by 2, 2. 3 plus 2, 5, divided by 3, 5/3. Oh, we got a fraction, that's a difficult number. 4 plus 2, 6, divided by 4, 6/4, which is 3/2. 7/5, and then 6 plus 2 is 8 divided by 6, 4/3. Very simple. All right, so if the arithmetic is too hard to calculate, let your calculator do it, right? Without even having to punch in 2 plus 2, it's going to give you all the terms of the sequence. Watch. So bring up my calculator, and I go, let's see. Try to grab my calculator, there it is. I'm going to find the sequence key. Okay, so it's kind of hard to find it. There isn't actually a button that says sequence, but I'm going to go to the catalog in the calculator. So right here, see right above the 0, you know how good it shows up here. It says catalog, it's in blue. So blue means hit the second button, the 0. And everything's in alphabetical order. So if I start with the A's, I got to go all the way down to the S's. So I can go up and start with the Z's and backtrack. It's kind of a little bit quicker. Or you can actually do this too. You can hit the alpha. It was already locked. And hit the S. The S is in green. Where is the green letter on here? I can't see it. It looks like maybe right here, I think, LN. Yes, okay. Brings you straight to the S's instead of scrolling all the way down. So that's a little shortcut. But you can scroll all the way down or scroll up. We want to go to SEQ. SEQ stands for sequence. And one of them that's already in parentheses because we got to put some parameters in there. So we can hit enter on that. The sequence is the formula that is given there. We had x plus 2 divided by x. So our entire numerator needs to be in parentheses. X plus 2 divided by x. Oop, not times x, divided by x. And then I put a comma. And that's the formula. And now I don't know why they asked you to do this again, but you need to describe what the variable is that you want to iterate. It's x, right? So it's x, type in x again. And then a comma from where to where. I want the first term all the way up to the 6th term, right? So 1, comma, 6. And then how do I want to increment from 1 to 6? By ones, right? 1, then 2, then 3. So I want to change the first to a 2, to the 3, to the 4. So increment, comma, by 1. So this is the only thing that might be a little bit more challenging is remembering the format of this and actually do the arithmetic, right? But when I hit enter, you're going to see all the terms in the sequence. Now they're in decimal form. I'd rather see them as fractions. So hit math, change to fraction. Done. That's your 6 terms in the sequence. So again, calculator can always verify your answers correctly as long as you know your formatting for those. All right, so the formula can get a little bit more complicated. It doesn't have to be something super simple like we just saw, but suppose I say a sequence of B of n is defined to be -1 in parentheses to the n power, then n divided by 2. Well, and if I want the first 6 terms, again, by hand, it's not too crazy. N is 1, plug it in. N is 2, plug it in. Or you can use calculator. Let's see, I already have most of it entered in here, so I'm gonna just change my formula right there. So if I hit second and entry, second and entry. There we go. See if I can change my formula. So I put a -1, raise it to a power, and call it x, multiply 2, parentheses, insert x divided by 2, close the parentheses. All right, so that's my formula. There's my variable, incremented from 1 to 6 by 1s. Hit enter. Again, I have fractions, change them. I have decimals, change them to fractions. There are my 6 entries there. -1/2, 1, -3/2. You see how the -1 to the power changes your entries, your terms by alternating negative then positive and negative then positive, because once you start raising to positive exponents, -1 is a positive, right? If you raise to even exponents, that gives you a positive value for that. Odd exponents makes the negative. All right, see if we can determine what the formula would be if given the pattern. This is a little tricky. Sometimes you just got to start with something, a formula that may work. Sometimes you see it right away. But if you don't see it, then you got to tweak it and adjust it to where it generates these terms. So let's say I have 1, 3, 9, 27. And the 3 dots that follow is called an ellipse. That just means continue that pattern. You usually want to have at least 3, 4 numbers listed so you can establish what the pattern is. So if I would say this is a sub n is defined as, that's too many squiggles. What formula? All right, you can see if it's exponents, right? This is exponential. 3 squared makes 9. 3 squared makes, 3 cubed makes 27. The next would be an 81 and so forth, right? So this is 3 to, we want to change the power, right? So the variable is going to be the power. So if I say just 3 to the n starts always with 1, right? I said that defines what a sequence is. The integers are positive, right? The first positive integer is 1. If 3 to the n, 3 to the first power is 3, right? That's the second term in the sequence. I want the first term in the sequence. So n still has to stay 1, but I need to say -1 right there. So if n is 1, 1 minus 1, 0, 3 to the 0 is the first term, 1, right? If n is now 2, 2 minus 1 is 1, 3 to the first, 3. So that's where you got to kind of tweak it. So you can kind of identify what's happening to generate the terms in the sequence, but then sometimes you got to make sure it's going to generate those exact positions, the first term, the second term, the third, and so forth. 1/2, 1/4, 1/8, 1/16. This one might be a little bit more obvious to see. Let's call this one B sub n. So you see the numerator never changed, so it's constant. So that tells you it has to be 1, right? But my denominator is changing. 2 to 4 to 8. That is powers of 2, right? So base of 2. I need the first term to be 2 to the first in the bottom. So this just has to be an n, right? 2 squared is 4. That's the second term in the bottom. 2 cubed, 2 to the fourth, 2 to the fifth, and so forth. See if you can come up with that one. And this one. Oh, this one's C sub n. This one's D sub n. And we'll put an E in here. All right, so 3, 5, 7, 9. So some odd numbers starting with 3. So you know you get even numbers. Multiply anything by 2, you get even, right? Well, odd is just 1 away from there, right? So if I say 2 times some number n, maybe the first term, that gives just 2, right? But I want to start with 3, so add 1 to it. If n is 2, that would make 5, right? 3 would make 7, and so forth. So 2n plus 1 is how that one could be defined. There might be other rules that work. Just make sure your rule that you choose when you put in n equals 1, then 2 generates these numbers. 2 to the n plus 1 like that. Let's see, if I put 1 in there, that would give 2 squared makes 4, right? Then 2 cubed makes 8, so it's not generating those numbers. That didn't work. All right, this one, 1, 8, 27, 64. Okay, that one's a little trickier. All right. All right, so this is the first term, second term, third term, fourth term, fifth term. So maybe that can help you see what n would be. This is n cubed, right? So sometimes they're not so obvious, but you just got to kind of play around with some things and see if it's going to generate those terms. All right, so this next one, you kind of just saw this. You should be able to get this one. If it was just 2, 4, 6, 8, I kind of just told you how to get that. But they're alternating signs. So to alternate signs, we put in a -1, right? And then we put it in. If n is 1, that's going to generate a negative. Well, I don't want it to be negative. I want it to be a positive to start off with. So 1 plus 1 makes an even exponent, makes a positive value, right? And then 2, 4, 6, 8 is just 2n. What's that? D. All right, so look, each term, the first term, the second term, the third term, the fourth, these are perfect cubes, right? 2 cubed, 3 cubed, 4 cubed, 5 cubed. Good. So it's like a puzzle. You just gotta sit there and try to figure it out. If y'all play Wordle, anybody, y'all got today's word? It's hard. I got it though. But it's kind of the same thing. You just take a guess at something and see if it works. If it doesn't work, start rearranging some things, okay? All right, so that is a little bit of information about how the pattern of sequences occur, or trying to figure out the formulas or rules of the sequence. Next thing we got to talk about is this, the factorial symbol. If n is greater than or equal to 0, is an integer, meaning 0, 1, 2, 3, 4, 5, negative ones, but we're not talking about the negatives here. The factorial symbol is, you just say n really loud, right? An exclamation mark. That's called n factorial. okay, is defined as you just shouted, right? That's how you define it? No. 0 factorial, this is always equal to 1. 1 factorial is equal to also 1. If I say 2 factorial, this is 2 times 1, which is 2. 3 factorial, you'll see the pattern. 3 times 2 times 1. 3 times 2, 6 times 1, 6. 4 factorial, you see these numbers grow pretty large very quickly. That's 4 times 3 times 2 times 1. That's 4 times 6. That's 24. I can keep on going, but obviously you're probably starting to get the pattern. So if I would say n factorial, this is n times 1 less than n times 2 less than n times dot, 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 all the way down to 3, then 2, then to 1. All right, so just show you where this number is in your calculator or this symbol. If I want to say, let's evaluate, I'm not going to put like 500 factorial. The calculator's going to start smoking. Okay, it's going to sit there and it's going to be 500 times 400 times 3. 500 times 499 times 498. This is going to take forever. It's going to be a huge number. So don't try to put those big numbers in. So let's just say if I have 12 factorial, 12 times 11 times 10 times all the way down to 1. It's going to be a big number, but the factorial symbol is on the math button. And if I go over to PRB, PRB stands for probability use. That's factorial symbols a lot in statistics. So well, we'll see maybe a little of that, but option 4 right there, enter. That is 12 times 11 times 10 times 9 all the way down. So 12 factorial is equal to, what should it stay up? 479,011,600. $479,001,600. All right, so they throw this in here in this section right now just because it's going to come back to haunt us later. Okay, so just get familiar with the factorial symbol. Might just have to evaluate some numbers like that. So instead of putting it into calculators by hand, 12 times 11, use the exclamation mark. All right, a recursive formula. All right, a recursive formula, all this does is tell you a definition, basically, of here is the first term to start with, and then apply some formula that generates the next term in the sequence, okay? So here's a second way of defining a sequence. Is to assign a value to the first term and specify the nth term by a formula. That involves one or more of the terms preceding it. All right, so this is called a recursive formula. So you got a first term and then the nth term defined by whatever the first term may be. So example, first term is given, let's call it S1 is a 2. Therefore, each term after S1, S2, 3, 4, 5, S sub n is defined as 4 plus S of n minus 1, the previous term. So you add 4 to the previous term. That's what that means. So this is very simple to do. N is equal to 1. This is S1 is 2, right? N is equal to 2. This means S2 is equal to, follow the formula and just put in 2 for N. This is 4 plus S of 2 minus 1, which is 4 plus S of 1. S of 1 was defined to be the previous of 2. So this is 4 plus 2, which is 6. You just keep up the pattern. N is 3. S3 is 4 plus S of 3 minus 1, which is 4 plus S of 2. S of 2 was the previous one found to be 6. That's 4 plus 6 is 10. And you can keep on going. Actually, you can pretty much determine what the pattern is. 2 got to 6 by adding 4 to it. 6 got to 10 by adding 4 to it. So n equals 4. S of 4 would be add 4 to 10, right? It's 14. And it's 5, add 4 to 14. And so forth. And keep on going on and on and on. Right. Summation notation. All right, so sometimes saying this plus this plus this plus this plus this is pretty tedious, right? So can I just say sum up all these terms? And all these terms are defined by a formula, right? So the first term, plug in something, second term, plug in something, you calculate them out, you get all these terms. Well, if you got 100 terms, you don't want to sit here and type it in the calculator 100 different times. So if they all share a specific formula, you type that formula in and you say sum them all from 1 to n, 1 to 100, whatever it may be. All right, so if I have a sequence defined as a sub n is a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus dot 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 all the way plus a sub n. I'm gonna sit there writing out maybe if I have 100 terms. Summation notation is going to be equal to the Greek capital letter sigma. You may have seen this. If you've used Excel before, you want to add up a column or a row. At the end of that column, you hit this little button, auto sum. Of what my formula would be. In the case this is my formula, I don't know it specifically, but here it is right here, a sub n, right? Okay, a sub n, okay. But I'm going to put a substitute letter, k. So that a sub k will start with k equals to 1 right here, all the way to the last term, in this case is n, so n at the top. K is called the index. It's usually a K, an I, sometimes J. It's usually the letters used for that. It tells where to start the sum and where to end it. Okay, starts at 1 and ends at n. So if I want to say k is equal to 1 to, let's say, 10 of k cubed, right, by hand. This is k is 1 cubed. K is now 2 cubed plus 3 cubed plus 4 cubed plus dot, dot, dot. I'm going to write them all the way to the last 10 cubed. So I'd have to sit here and do all these cubes, right? Put them in the calculator. 1 cube plus 2 cube plus 3 cube plus 4, blah, 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 blah. Shortcut. In the calculator. Now, if you got the TI-84 calculator, you have an advantage over those that don't have the, that have the 83. Okay? So TI-84 calculator, all you have to do is hit the math button, turn it on first, scroll down, and you see summation with the Greek letter sigma. You hit enter, and it looks exactly what you have to type in, right? Except I don't have a variable k in my calculator. I have the variable x. I use x. X equals 1, arrow up, to 10 of x cubed. I hit enter, it's going to sum 1 cubed all the way to 10 cubed. Boom, 3025. That's simple. If you have the TI-83 calculator, we need to sum the sequence. Right. So what I have to do is go to the calculator again. I mean the catalog, that is. Second catalog. I'm going to go to the S's again. So I'm going to hit alpha is already locked. You see my little A up here? That just means it's locked for you. So the next button that I hit corresponds to the green letters. I want an S. And I'm going to find sum. Eventually comes up. All right. So in 83s, you're not going to see summation with the sigma. You'll just see the sum. Hit that of the sequence. Back again, catalog. S's again. SEQ. Uh-oh. Right there. My formula for this is x is q. The formula is right there. Comma, what's the variable? I'm iterating x from where to where? 1 to 10. And how am I iterating from 1 to 10? By ones. So this closes off the sequence, this closes off the sum. And when I hit enter, I also get 3025. So sum the sequence for that. So yeah, if you got the 84, it's how easy it is. Visually just change over everything, but just place your variable as x instead of k. If I give you the sequence, you tell me what the summation is. So let's say if I say 1/3 plus 1/9 plus 1/81 plus dot 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 plus 1 over. What you think goes here? What is the formula that is used to generate these numbers here? It's 3 to the first, 3 to the second. I missed one of them. There's a typo on here. This is supposed to be 27. Let's erase that. 3 to the first, 3 squared, 3 cubed. Then I had 3 to the fourth, and so forth, right? So this is 3 to the n. It's the last term. N is 1, 2, 3, 4, all the way to the end. So right here, this last expression right here tells you what your formula is to generate all the previous ones, right? So this is summation as k goes from 1 all the way up to n. We don't know how many it is, but that's the formula of 1 over 3 to the k power. Make sure you use a k if you're going to write out what this sequence is, and the summation that is. Let me tell you right now, I usually have a question similar to this on the test and said, actually give me the summation notation. A lot of people, they get the formula correct in a sense because you're looking at it, but they get the variables mixed up because your index is k, okay? So you got to use your k in here to show that it starts and ends, starts at 1, ends at n. All right, some properties of summations. For you guys, since you could use your calculator a lot, you probably don't need to use this a whole lot because we're not going to be doing summations a lot by hand. But when you get to calculus, and if your professor starts doing a lot of proofs and stuff with summations in there, which you may get to see that, you got to prove using properties of summations. I remember seeing this when I was in, and I'm like, where are they getting this? But this is where it comes from. So some properties, they're not too difficult to see, or even to use examples to illustrate how they work. Summation as k goes from 1 to n of c times a sub k, where c is a real number. So it's like a coefficient in front, like 5 times something, whatever, I don't know. This is just, this c can come out. Basically, it's a constant, it's a common factor in every one of these terms, right? So this is c times a sub 1 plus c times a sub 2 plus c times a sub 3 all the way down to c times a sub n, right? So if I factor out the c, that's c times a sub 1 plus a sub 2 plus dot 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 all the way to a sub n. This is just equal to the constant c multiplied to the summation as a sub 1, a sub k that is, where k goes from 1 to n. If you got a constant in front of a variable, take it out, bring it out in front. If you have a summation of term plus term plus term plus term, you can split that up as summation of a term plus summation of a term plus summation of a term, make it easier. So it just shows 2 of them, a sub k plus b sub k. The summation of just the a sub k plus the summation of the b sub k. Subtraction's the same as well, so if I put minus, you can subtract them. All right, suppose I don't want to start at 1. Suppose I want my summation to start at like 5. Well, I can sum 1 through whatever it's going to, and then take off 1 through 4. Now I have 5 to the rest, right? So this is the notation for this one. Again, I wouldn't memorize all the lettering in this, when you get to the problem where you have to sum starting at some other number beginning other than 1. So k is not starting with 1, it's starting somewhere else beyond this. This is summation as k goes from 1 all the way up to n minus the summation as k starts from 1 all the way up to j. You're taking off the beginning. And I forgot my a sub k. Right here? Yeah, minus. See the plus or minus right there. So and just some side notes, some formulas. If you want to sum some sequential, just say constants. Say C is a constant, 5. And you want to say sum it from 1 to 10. So first term is 5, second is 5, the third is 5, all the way 10 terms of 5s. Well, that's 5 plus 5 plus 5 plus 5, 5. That's just 5 times 10. So this is just n times c or a c times n, either way, where c is a real number. Don't worry about memorizing these. These are just helpful sometimes when you don't want to do quick mental calculations sometimes when adding numbers, especially if sequential numbers. You start with 1 and you want to add all the way to 1,000. Break out the calculator. 1 plus 2 plus 3 plus 4, right? All the way to 1,000. There was a shortcut for this. You don't have to add in a specific order. You can add in any order, right? So think about it. If I'm going from 1 to 1,000, the endpoints, 1 plus 1,000 is 1,001. The next number is n. 2 plus 999 is 1,001. 3 plus 998 is still 1,001, right? So you keep on going, you're splitting that 1,000 entries into half, right? Now you got 500 entries. But the first one is the sum of n plus 1. You say n times n plus 1 divided by 2. That's the formula for that. So that's a quick little shortcut to sum sequential numbers. That actually was derived by Carl Gauss, was his name, in 1800s or something. I think it was 1800s. Teacher gave him some busy work and said, add up all these numbers, 1 through 1,000, or something like that. So she thought they'd be there for hours, you know. And he stands up and has the answer. Da, 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 da. How'd you get that answer? Like just exactly what we just said. Take the n's, and then you have that many factors. All right, k squared. If you want to look at that one's similar. That's 1 squared plus 2 squared plus 3 squared. That has a formula of n times n plus 1 times 2n plus 1 all divided by 6, if you want to use that formula. There's one for k cubed too. It's this one right here, all squared. It's n times n plus 1 all divided by 2. That entire quotient is squared. So again, I wouldn't memorize these. I just think that first one and the second one are fairly useful most of the time. I might have something that says illustrate the properties, meaning expand this as much as possible, I guess. Now, obviously, you can put this in a calculator and actually calculate what it is. But if I didn't have a calculator, then this calculator broke. I can say, okay, well, this one is the summation as k goes from 1 to 24 of k squared. I have a k squared formula, I can plug that in, plus 5 times k, 5 is the constant, it can come out, 5 times the summation as k goes from 1 to 24 of just k. I have a formula for this. And then this is a constant right here, minus the summation as k goes from 1 to 24 of 3. And so by hand, n is 24, n plus 1 is 25, divided by 2. This is 5 times, oh, I'm sorry, this is the wrong formula. I'm looking at k to the first power, k squared. So we still got to use what we have in here, except alter that. 24 times 25. 2 times 24 is 48, plus 1, 49. All divided by 2. This one here is 5 times 24 times 25 divided by 2. And this one is C, 3 times N, 24. All right, so these individually, I'll tell you, comes out to be, let's see, where was it? This one's 4,900. This one here, you can do the arithmetic, and that comes out to 1,500. And this one is 72. All total 6328. I don't require you to do this. I pretty much like you just to expand the summation, illustrating the properties. That's about it. You don't have to know the formulas to calculate by hand. You can use a calculator. All right, that's sequences. Not bad. Lots of calculator work too. So demonstrated some of the properties and stuff, not too difficult. But like I said, when you get to calculus, you may see more of those properties used. A lot of times in proofs.